In this video, I'm going to go over various examples relating to rational expressions. First example, let's evaluate the following expressions at the specified values of x. First expression is 3x plus 1 over 5x. We would like to evaluate that at x equals 2. So we simply solve the problem by plugging in x equals 2 into the expression. Part A. Three times 2 plus 1 divided by 5 times 2. That's 7 over 10. Part B. To evaluate the expression at x equals minus 3, simply plug in x equals minus 3 into the expression. 7 minus 3 times negative 3 divided by 3 times minus 3 squared minus 7 times minus 3 plus 2. That's equal to 7 minus 3 times minus 3, that's plus 9, divided by minus 3 squared is 9 times 3, that's 27. Minus 7 times minus 3 is plus 21, plus 2. And that's equal to 16 divided by 27 and 23, that's 50. And the fraction 16 over 50 simplifies to 8 over 25. Next type of example, find the values for which the following rational expressions are undefined. Now you're dealing with rational expressions. They are undefined precisely when the denominator is equal to 0. Starting with example A, we say that 5m plus 2 over m squared plus m minus 6. This is undefined when the denominator m squared plus m minus 6 equals 0. Well, m squared plus m minus 6, we can factor that as m minus 2 times m plus 3 equals 0. And using the zero factor property, we have m is 2 or m is negative 3. So, the expression 5m plus 2 over m squared plus m minus 6 is undefined precisely when m is 2 or m is negative 3. Moving on to the next example, when is 4x squared over 3x plus 5 undefined? Well, this is undefined when 3x plus 5 equals 0. Well, when is 3x plus 5 equals 0? Precisely when x is minus 5/3. So the rational expression 4x squared over 3x plus 5 is undefined only at the number minus 5/3. Moving on to 4q plus 2 over q squared plus 9. This is undefined when q squared plus 9 is equal to 0. However, look at the expression q squared plus 9. If q is a positive number, and we square it, we get a positive number. Plus 9, that's a positive number. So for any positive number, q squared plus 9 is positive. If q equals 0, we get 0 squared plus 9, which is 9, and that's positive. And if q is any negative number, we square it, that results in a positive number. Add that to 9, you get a positive number. So no matter what real number we plug in for q, q squared plus 9 will always be greater than 0. Okay? This is true for all real numbers. For all real numbers, the rational expression 4q plus 2 divided by q squared plus 9 is defined. So the expression 4q plus 2 over q squared plus 9 is defined for all real numbers. Moving on to the third type of examples, we would like to write each of the following rational expressions in lowest terms. Recall that lowest terms means the numerator and the denominator have no common factors other than 1. Starting with the first example, 6m minus 18 over 7m minus 21. In the numerator, we can factor out a 6, and that leaves us with m minus 3. In the denominator, we can factor out a 7, and that leaves us with m minus 3 as well. Cancel out the common factors, m minus 3, m minus 3, and that leaves us with 6 over 7. So the expression 6m minus 18 divided by 7m minus 21, if we write that in lowest forms, the answer would be 6 over 7. Next, let's look at 7t squared minus 31t minus 20 divided by 7t plus 4. First, I'm going to factor the numerator, 7t squared minus 31t minus 20. To factor that, I need two integers, p and q, that multiply to 7 times minus 20, that's negative 140, and add up to the coefficient of t, which is negative 31. If we go down the list of factors of negative 140, we will see that p equals 4 and q equals negative 35 will do the trick. In other words, 4 times negative 35 is minus 140, and 4 minus 35 is equal to minus 31. So we write 7t squared minus 31t minus 20. In factored form, that would be t plus 4, t minus 35, multiply by 7, and divide by 7 accordingly. So in factored form, we get 7t plus 4, t minus 5. So going back to our expression, 7t squared minus 31t minus 20 divided by 7t plus 4, we can write that as 7t plus 4 times t minus 5 divided by 7t plus 4. Let's cancel the common factor, 7t plus 4, and that leaves us with our final answer, t minus 5. Finally, let's write the expression km plus 4k minus 4m minus 16, all divided by km plus 4k plus 5m plus 20 in lowest form. So to do that, I'm going to start out by looking at the first two terms in the numerator, km and 4k. They have a k in common, so I'm going to factor that out. If we factor out a k, we're left with m plus 4. Now look at the last two terms of the numerator, minus 4m minus 16. I'm going to factor out a minus 4. That leaves us with m plus 4. I'm going to do something similar in the denominator. Km plus 4k, we factor out a k, we're left with m plus 4. And the last two terms of the denominator, 5m plus 20, if we factor out a 5, that leaves us with m plus 4 as well. Now looking at the new numerator, we have an m plus 4 in common. If we factor that out, we're left with a k minus 4. In the denominator, we also have an m plus 4 in common. If we factor that out, we're left with k plus 5. Look at the common factors, m plus 4, they cancel out. And in lowest forms, the expression is k minus 4 divided by k plus 5.